All right, now here's another example. We have 2x to the 4 minus 4x squared plus 1, and we're asked to find all of these. So it's a pretty good much review for the entire section here. We're going to find the turning points, min and max. We're going to find intervals of increase and decrease. We're going to find intervals of concavity, concave up, concave up, and concave down. And of course, you can find the POIs. So first things first, we have to take the derivative of this. And by the way, this is on page 248. But you know, I like the way I do it myself actually. So take the derivative of it. So it'll be 8x cubed minus 8x. And the derivative of this is 0, so it will be equals 0. Again, what we're doing, why make it equal 0? Because we're trying to find plateaus. All right, so if I factor this, there's 8 on both sides, 8x on both sides. So it'll be x squared minus 1 equals 0. From here, x equals 0. And this will be x squared minus, well, equals 1, bring 1 to the other side, or x equals plus minus 1. Okay, so there's actually 3 plateaus, and those are the only 3 plateaus that we know of. Okay, so it's actually 0, and here's minus 1 and 1. It plateaus at these points. Okay, where are those points? Well, we can actually figure it out, like plugging those values into the original equation. Oh, here it is, okay. So if we plug in 0, will be 2 times 0 to the 4 minus 4 times 0 plus 1, well, it's 1. So at 0, it's at value 1. Okay, actually I'm gonna make this higher. Okay, plateau's there at 1. Okay, now I'm gonna plug in minus 1. So it'll be 2 minus 1 to the power of 4 minus 4 to the power of minus, so 4 times minus 1 plus 1 equals, and if you plug that in, you get minus 1. Right? So it'll be minus 1 over here somewhere. So plateaus, so it's minus 1 comma minus 1. And then if you plug in 1, so this is squared, my bad. Right? 4 minus 4 comma 1 squared plus 1, it's also minus 1. Okay, so it'll be 2 minus 4 plus 1 minus 1. Okay, and this will be 2, well, this makes it positive because it's the power of 4. So 2 minus 4 plus 1, same answer. Okay, so we know it plateaus at those areas. You can probably see what's going to happen already. It's going to go like this, right? But anyway, now, just to be sure, well, we can put values of a half in here between this one and find out what the slope is. But you know what? I'm not going to do that. I'm actually going to find the concavity. So here's y double prime of y double prime. So now I'm going to look at this. This will be 24x squared minus the derivative of this one is 8 equals 0. Again, what am I trying to find here? When I take a double derivative, what I'm trying to find, I'm actually trying to find the points of inflection, which is where the double derivative is 0. Okay. Okay, so we got 24x squared minus 8 equals 0. If I move that 8 over, it'll be 24x squared equals 8. Divide both sides by 24. You're going to get 8 over 24, which is 1 over 3. Okay, take the square root. Again, it will be plus minus 1 over root 3. Okay, we're taking the square root, so it'll be plus minus 1 over root 3. So what is 1 over root 3? 1 divided by root 3 is approximately 0.57. So it's about here somewhere. 0.57 minus 0.57, because it's plus and minus. and here's the other one is what's about here. It would be 0.57 positive. Okay? Now, if I plug in 0.57, I'll actually get the point of where it is. So I plug in back in the original equation, 1 over root 3 equals, plug it back into the original equation up here. So it'd be 2 bracket 1 over root 3 to 4 minus 4 1 over root 3 squared plus 1. Well, if you think about it, you can do this in your head. Root 3 times root 3 is 9, and then root 3 times root 3 is 9 again. I'm sorry, root 3 times root 3 is 3, because I'm thinking ahead of myself. And then root 3 times root 3 is 3 again, so 3 times 3 is 9. So it'll be 2 bracket 1 over 9, right? Minus, this is 4 over 1 over 3, plus 1. When you work it out, it becomes 1 over 9. All right? Now, without doing much work, because if I'm going to do y prime of 1 minus root 3, you can see that it will be the same answer. Sorry, it'll be, my bad, it'll be minus 1, 9. Okay? And if you plug in minus, it becomes the same answer because it will become positive up here, so it'll still be 1 over 9. So therefore, the point of inflection is 1 over here, it's not very accurate, and 1 over here. Okay? So therefore, this is 1 over root 3, and then minus 1 over 9. And this here is 1 over root 3, and minus 1 over root 3, and 1 over 9 is, again, minus 1 over 9. These are point of inflections. Okay? So we have 2 points of inflection. All right. And then what we can do is find out the concavity. Now, if I plug in 0 into the double derivative, I can find out what the concavity is, right? So y double prime, if I plug in 0 into here, it would be 24 times 0 squared minus 8. Well, it's actually negative, therefore it's concave down. And it makes sense. It's concaving down here, right? Concave down, like that, okay? If I plug in y double prime of the other plateau minus 1, it'll be 24 minus 1 squared minus 8. Well, obviously that's positive, okay, because this number, when you square, becomes positive, right? So it concaves up from here on in, like that. Has to concave up. And the same thing with y double prime at 1, because I'm plugging 1 into here now. So it'll be 24 1 squared minus 8. It's still positive, so it will concave up this way. All right? And then by that concavity, we can tell that this is an absolute or global max. Sorry, global min. And so is this one. And this one, well, it's not a global because these values go higher. Okay, these values go higher, so it has to be a local max. Okay, so we have all the information we need now. So where are the intervals of increase? Well, we can see it increases from here to here. So it'll be minus 1 comma x comma 0, right? From here to here. This is where it increases. This is where it decreases. This is where it increases again. And this is where it decreases. And the other place is at x greater than 1. That's the other increase. Where does it decrease? Well, it decreases when x is less than minus 1, obviously. And it also decreases between 0 and 1. Okay, so that's the interval. So we took care of the intervals increase, decrease. Where does it concave up? So it concaves up where? Well, we now have to consider the point of inflection because that's where the border is. So it concaves up between, well, to the left of, well, this actually minus 0.97 is actually this one right here. So it'll be x is less than minus 1 over root 3, which is basically 0.57. Okay, negative 0.57. And it also concaves up when x is greater than positive 1 over root 3. Again, you have to consider where the point of inflections are, because that's where the border is between the concavities, between concave up and concave down. Okay, and then where's the concave down? Well, there's only one spot. It's actually between here and here. So it would be minus 1 root 3 less than x less than 1 over root 3. Okay? So there's all the information you need that I took. The turning points are 3. There's actually 3 turning points. It's here, here, and here. 3 turning points. The intervals of concavity is right here. The intervals of concave up and down is right here. Okay? And the point of inflection I just highlighted here. I'm going to use another highlighter, green ones. These are point of inflections. Okay? Those are the point of inflections. The only way to get better at it is practice. The only way you can get good at this, guys, is practice, practice, practice. Okay? So again, I took this page out of 248.